So here's what we're talking about circles today, and we're going to talk about some word problems essentially, or how to set up a few word problems. So let's first talk about the equation of a circle. And really, you're welcome to follow along on the notes. The notes are very similar to what I'm going to be writing. I might, if we have time, do one or two extra examples, but usually all the time is pretty well spoken for. So the equation of a circle is given by the following: x minus h squared plus y minus k squared equal to r squared. This is the standard form. And typically, so sometimes people will use the word standard form, sometimes people use the word general form. Usually when I hear those words, typically people, when they say standard form, it's usually the form that gives you more information. Like when we talked about the, oh gosh, I feel like I'm totally forgetting the word. No, I guess maybe, so like when we're talking about lines, y equals mx plus b is usually called the standard form of a line because it gives you a lot of information. It tells you what the slope is, it tells you what the y-intercept is. Whereas the other form, the ax plus by equals c form, is the general form. But it doesn't actually give us a ton of useful information about the thing we're dealing with. Same kind of thing is true here. This is the standard form of a circle, x minus h squared plus y minus k squared equals r squared. And looking at this equation, we can automatically see that the center of the circle is the point h comma k, and the radius of the circle is r. And I'll just point out, because we will see this today, you can also write a circle in the general form, which looks more like this. Ax squared plus by squared plus cx plus dy plus e equal to 0. This will also be a circle as long as a and b are the same. There's one little caveat. But this way of writing the equation of a circle really doesn't tell us a whole lot. So we're going to see an equation like this, and we're going to talk about how you can manipulate it so it looks like this and actually tells us something useful. So this is how you would prefer to see your circles, just like that. And so the way I usually think about where the center is, it's the x and y coordinate that make each of these things equal to 0. So if x is h and y is k, this is 0 and this is 0. All right, so let's do a couple things. So I want to graph the following circle. So I want to graph, what do I got here? X minus 2 squared plus y minus 3 squared, yeah, equal to 25. And so to graph a circle, I want to find the center and the radius, because that's really all I need to know to be able to graph it. Oh, also, before I forget, I think everyone's here, but gotta make sure I take roll later. Okay, good to go. So the center here is x is going to be 2 because 2 minus 2 is 0. Y is going to be 3 because 3 minus 3 is 0. So there's my center. My radius, well, I know that this over here is the radius squared. So I could actually, I think we know what it is, but I could actually write out r squared equals 25 and then take the square root of both sides to get r equal to 5. The radius is just positive 5. It's not plus or minus 5, right? When we're talking about the radius of a circle, it never makes sense to think of it as a negative number. It should always be a positive number. One thing I should mention is that the center, although it's a really important point, it's actually not a point in the circle, or I should say a point on the circle, right? The circle is really only the points that satisfy this equation. And if you look at this point here, if you plug in 2 here and 3 here, I get 0 plus 0, and that's not equal to 25. So just so you're aware, the center is super important, but it's not actually a point on the circle. So let's see. So the way I'm going to graph this, and I would probably actually draw some little marks. Let's draw a little marks. I don't always like to draw these. I don't usually like to draw these, but sometimes we need to draw them. So I'm going to plot the center, even though it's technically not a part of the circle. So it's 2, 3. And then I find the easiest way to graph a circle is to go the distance of the radius in each of the 4 directions. So so I'm going to go 5 up, 5 right, 5 down, and 5 left. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I'm just going the radius in each of the 4 directions. I don't think you need to label any of these points as long as it's clear what they are, but you could. Right? This is the point 2, 3. This point, which is 5 to the right, is 7, 3, because I added 5 to the x coordinate. This point up here is 2, 8 by adding 5 to the y coordinate. This point over here is -3, 3 by subtracting 5 from the x coordinate. And this point down here is 2, -2 by subtracting 5 from the y coordinate. And then we try to draw the best circle we can, which can be challenging. I think I did a pretty good job. I've had a lot of practice, so my circles are usually okay. What else? See, this chair is in the way. Sorry, I don't know what I'm saying. One thing you should know, and this is kind of a rarity when it comes to things I have you graph, is that for circles, we don't worry about finding the intercepts. We certainly could find them if we wanted to, and we would find them in the usual way, right? I could find the y-intercept by setting x equal to 0 and then solving for y, but it's not really an important piece of the graph of the equation, so we don't bother. So that's how you graph a circle. Plot the center, go the radius in each of the 4 directions, plot those points, and then circle. All right, so let's look at, before we look at the next thing, and also if I'm going a little too fast, like if I flip the board and you're like, James, I want to see something, let me know. I can always flip it back. There also will be video not too long after class is over. So I will definitely post the video after class. But if there's something like, oh, I just need one more little thing, I'm happy to go back for a second. And actually, I want to do one more example before I say this next thing. So I'm going to kind of go over here. Yes. So here is a question that shouldn't be too terrible. So this actually isn't in the notes for this section. I added this question in. So what is the equation of a circle with center 4, -3 and radius 8? So all I'm really going to do here is think about what the equation of a circle is. I know the general equation is x minus h squared plus y minus k squared equal to r squared, where h comma k is the center and r is the radius. So using 4, -3 as the center, that means I should have x minus 4 squared plus y minus -3 squared equal to 8 squared. Let me ask you this: can you see that all right? I feel like it looks a little not wonderful on the screen. Is it okay to see it?
It's
Yeah.
kind of a little.
Let me try adjusting one setting here. I think the issue is that I have turned on the, oh gosh, where'd you go? The adjust for low light setting. And while it makes my face easier to see, it makes the board harder to see. How's that? Is that a little better? Yeah, okay. We don't need to see my face. It's not that important. Or at least we don't see my face in as good a light. I'll just look dark and you can see the board, which is definitely more important. Okay, so do that though. Yeah, that is better. Except for that. Sorry, there's also, I can also see glare from my computer screen. So there, that pops up a little bit. All right, so in this case, we should simplify our answer just a tiny bit. We should definitely write this as x minus 4 squared plus, this should be y plus 3 squared, and 8 squared is 64. So that's how we should write our answer. So it's just a little simplified. Still pretty happy with the circle. So a couple other formulas that we want to be aware of. Sorry, I should speak at you. A couple other formulas we would like to be aware of are the distance formula. So the distance between 2 points. And we typically call those points x1, comma y1, and x2, comma y2. Is given by, we usually call it capital D, and it's the square root of the difference in the x's squared, so x2 minus x1 squared, plus the difference in the y squared. And I really want to emphasize, we can't simplify this as is, right? This is the formula. It doesn't get any nicer. You can't take the square root of each of these parts and just say it's like x2 minus x1 plus y2 minus y1. And then the other formula we would like to be aware of is the midpoint of 2 points. Again, x1, y1, and x2, y2. Is given by, sometimes we call it capital M. So when I think about the midpoint of 2 points, I think about the middle of those 2 points, or another word I could use is also the average of those 2 points. So when I'm thinking midpoint, I'm really thinking average. And it literally is the average of those 2 points, meaning I'm going to take the average of the x's. So the x coordinate is going to be the average of the x's, which is x1 plus x2 divided by 2. And for the y coordinate, it's going to be the average of the y's, which is y1 plus y2 divided by 2. That's how you find the midpoint of any 2 points. You just average them. And so now we're going to use these two things to do the following. Where'd you go here? I think I lost my question. It's all right. It's hiding from me. Oh no, it's right there. It's right in front of my face. I'm just not seeing it. Hopefully you guys' first week is going all right. I mean, I know it's a short first week, so it shouldn't be too bad. I will try, after class, I will probably work on grading your homework. So hopefully I get it graded pretty soon so that you can have the feedback of me reading it. So here's what we want to do next. We want to, find the equation of the circle with a diameter that passes through the points -6, 1, and 2, 7. So I'm going to draw an approximation of the circle. We're not, the question doesn't actually ask us to draw the circle, so we don't need to draw it. But I'm going to draw a guess at the circle image just to point out a couple things. So I don't really need a coordinate axis system. Let's say it's here. -6, 1 is about right there. 2, 7, maybe about right there. So my circle looks kind of like that. And these points here, -6, 1, and 2, 7, those points on the circle, they have a diameter that passes through them. Meaning, so there's a diameter that passes through those 2 points. And something that's true about the diameter circle, not that I've drawn it very well, I've drawn it actually pretty terribly. The diameter of a circle should go through the center. My picture is maybe not super excellent when it comes to that aspect of it. You can maybe make it look a little bit better. There, that looks maybe slightly more plausible. So we want to write the equation of the circle. To be able to write the equation of the circle, we need 2 things. We need the center. We don't have it. We also need the radius. We don't have it. So what we're going to do is we're going to use the equations we just talked about to help us find those things. So you could actually do either thing first, really. You could either find the center by using the midpoint, or you could find the radius by finding the length of the diameter and then cutting it in half. I would personally prefer to find the center first. I think that makes more sense. Because then what we'll actually do is we'll find the length of the radius by just finding the distance between the center and one of the other 2 points. But either way would be fine. So to find the center, I'm just going to use the midpoint. So it's the midpoint, and that's going to be the average of these 2 points. So the x coordinate is going to be the average of the x's, which is -6 plus 2 over 2. And the y coordinate is going to be the average of the y's, which is 1 plus 7 over 2. That comes out to be -4 over 2, which is -2. And that's 8 over 2, which is 4. So there's my center. My 4 looks a lot like a 9, I feel like. Make that look more like a 4.
Professor,
So now, if I want to find the radius, I can find the distance between my center and either one of these points. I can find the distance from my center to this point. I can find the distance from my center to this point. And they should be the same. So it shouldn't really matter which one I do. I think in the notes I did this one, so I'll do that one. So I want to find the distance between -2, 4, which is my center, and let's say 2, 7. So that's going to be the square root of the difference in the x's squared. So -2 minus 2 squared plus the difference in the y squared. So 4 minus 7 squared. It doesn't really matter which order you subtract them in. You can do these ones minus these ones or these ones minus these ones. Since you're squaring the results, it's going to come out to be positive either way, right? If I did 7 minus 4, that would be 3, and 3 squared is 9. Here I'm doing 4 minus 7, that's -3, and -3 squared is 9. So either way you subtract, as long as you make sure, you do have to make sure it's x's with x's and y's with y's. So you have to do x minus x squared, y minus y squared. So we're going to get the square root of -2 minus 2 is -4 squared. 4 minus 7 is -3 squared. So let's see, that's going to be square root of 16 plus 9. And I I've actually picked this example on purpose to point out that when you take the square root of a sum, you have to actually add the things and not just square root each part. So the square root of 16 plus 9 is the square root of 25, which is 5. It's not equal to the square root of 16 plus the square root of 9, which would be 4 plus 3. So be careful, because I know that's a very common mistake that people often make, is breaking up a square root when you can't actually. So we found all the stuff we needed for the equation, but we actually haven't written the equation yet, right? I found the center, I found the radius, but now I actually have to write the equation. So I'm gonna erase my graph that I don't actually need. So my equation is going to be x minus something squared plus y minus something squared equal to something squared. And the thing that goes here is the x coordinate of the center, which is -2. The thing that goes there is the y coordinate of the center, which is +4. And the thing that goes there is the radius, which is 5. So then I would do one additional thing. I would rewrite it as x plus 2 squared plus y minus 4 squared equal to 25. I really wish there was a way when I pin my video, which I definitely need to do so that the recording looks normal. I wish there was a way to see all of you, but I can only see 5 of you. So I'm going to scroll through back and forth on occasion, but I can only see some of you. I hope you're all doing well. It's nice to see your faces. Thank you for being on video, even if I can't see you. But I can see all of you. If I look right.
I think you can do it if you view.
Just as a quick check, I want to remind you guys, because this is really the way I think of it. If I look at this, I know that I've got it right, because if I plug in the center, I get 0 on the left. If I plug in -2 for x and +4 for y, this is 0 and this is 0. So that's how I always know that I've actually got the center correct. All right. Let's see. Yeah, okay. So I know I didn't do a completing the square example last class with the parabolas, but I did post a supplementary video showing a completing the square example. And while I won't, my goal is always to get through the notes each class. Occasionally I will not, because sometimes I just talk too much. So if I don't get through the notes, my plan is typically going to be to make a short 10 to 15-minute video covering whatever I don't get through. You obviously don't have to watch it. You don't have to come to class, right? I certainly want you to come to class. I encourage you all to come to class. And I definitely want you to watch the videos if I post them, but right, you don't have to do anything. Yeah, I know I can change it to gallery view. The problem is if I change it to gallery view, then if you watch the video later, you will see the gallery view. And so the board will look super tiny. So I appreciate the feedback, but I've tried that before and it doesn't work later for the video, which is too bad. Oh well, I won't get to see everybody. It's okay. Oh, my back kind of hurts. It's because I'm old. It's all right. So here, the reason I mentioned completing the square is because this next example, which is going to be written in the not standard nice way of writing a circle, is going to need us to complete the square. Let me tilt that down just a little bit. Trying to keep the board, in frame. So, let me check. Sorry, I know there's one more thing I need to worry about. One sec, sorry. No, I've got that, okay. Yeah, I'm good. Never mind. All right. So I want to know, what are the center and radius of the following circle? X squared plus y squared plus 2x minus 3y plus 11/4 equals 0. So here's a circle written in the general form. And we know it's a circle because x squared and y squared both have the same positive coefficient, right? So just so you're aware, if one of these was negative, we'd have something completely different. It'd be like a hyperbola. And if these had different coefficients, like one of these had a 3 and one of these had a 4, it'd be an ellipse. But if they have the same coefficient and they're both positive, then we have a circle. So just something to know. It's not really going to come up in this class, but it will come up like in, well, it depends on what series you're going into. It might come up in the sixth, I don't know. It comes up somewhere sometimes. But we'll talk about it later. We have to talk about it. So here's what we're going to do. First, we're going to bring any constants over to the right. So I'm going to have x squared plus y squared plus 2x minus 3y equal to negative 11/4. Easy. Second thing, which doesn't apply for this example, if there is a coefficient of x squared and y squared, we're going to divide everything by that coefficient. Not applicable here. The third thing we're going to do is we're going to group the x's and y's each together. So meaning I'm going to group all the x's, so I'm going to write x squared plus 2x. And I'm actually going to leave myself a little bit of space out here. I'm going to y squared minus 3y. I'm not space over there. Okay. And here's where the completing the square is going to happen. So we're going to complete the square for the x's and for the y's. So the way we do that is we take this coefficient of x, positive 2, we divide that by 2, and then we square it. And that's what we add right there. And we do this, and then if we add it over here, we have to add it over here. And then we do the same thing for the y's. We take the coefficient of y, we divide that by 2, which doesn't really simplify like it did here, and then we square it. And we get 9/4. And if we add it here, we also add it over here. So, my sock is doing something weird. I'm going to erase this part because I think we can let this part go here. Here's what ends up happening. And this is really kind of the important part of what's going on here. When we complete the square, the reason it's called completing the square is because it allows us to take this expression and write it as something squared. This part here is going to become x plus 1 quantity squared. The long way to think about it is you're just going to factor it. Right? You're looking for things that multiply to 1 and add up to 2. Well, that's 1 and 1. So you get x plus 1 times x plus 1, which is x plus 1 squared. Same deal here. You're looking for things that multiply to 9/4 and add up to negative 3. Well, that's negative 3 halves and negative 3 halves. So you get y minus 3 halves squared. The easier way to do it is to recognize that it's always going to be your variable plus whatever this number is right here. So your coefficient divided by 2 is going to be what goes there. So here it's x plus 1 quantity squared. Here it's y plus negative 3 halves, or y minus 3 halves quantity squared. On the other side, we have negative 11/4 plus 4/4 plus 9/4. So that's going to be, let's see, negative 11 plus 4 is negative 7. Negative 7 plus 9 is positive 2. That's going to end up being positive 2/4, which I would reduce to 1/2. So there's the equation of our circle. But that's not our final answer, right? The question wasn't to write the equation of the circle. The question was to tell us what the center and the radius are. So it's really important that we answer the question that's being asked. Yeah, I suppose I could fit it in right here. Sorry, I'm always at a, space is always at a premium on this small board here. So actually, I want you guys to take a minute and write down what the center is on your own. If you're taking notes. If you're not, just think about what it is. No, I don't. I'm looking at my watch like I have a second hand on it. All right, so the center I'm getting is x is -1 and y is +3/2. My 3 looks terrible. My radius, well, I know that this part over here is the radius squared. So the radius squared is 1/2, which means that the radius is the square root of 1/2. And that would probably be fine, but you could also simplify that. And if you take a square root of a fraction, it could really be the square root of 1 over the square root of 2, which we could write as 1 because the square root of 1 is 1 over the square root of 2. That would probably be fine. You could also even rationalize that and multiply it by √2 over √2 to get √2 over 2. That would be, there's probably 3 perfectly good ways of writing the radius. So here I want to point out, unlike our previous examples, the radius is not a whole number here, right? Our radius here is an irrational number, right? It's like, if you put this in your calculator, it'd be about 0.707, but that's just an approximation. I should I mention? Yeah. That if we, so we weren't asked to graph this, but if we were asked to graph this, it would be slightly more challenging because our radius is not a whole integer. So here's what I would do if I was having to graph this. Find my center. So the center is -1. +3/2, which is 1.5. So my center is like right there. And then my radius is, I said it was about 0.707. All I know is that's a little bit less than 1. So I would just say, well, it's not quite 1, but it's more than 1/2. So I would go like up a little bit and down a little bit and over. It's not quite 1, so I'm not crossing the y-axis, and over, not quite 1. So what I'm really trying to say is you don't have to be super precise. If your radius is some irrational number, just try and figure out what integer it's close to, and then say it's a little bit less than that or a little bit more than that, depending on what it's close to. All right. I think we have another example. I think I'm doing all right on time. I might feel like I'm going to jinx myself now. I just said I was doing all right on time. I'm probably not going to finish everything I want to finish. It's okay. I will also remind you guys, if you have questions, feel free to stop me. I imagine this might be review for some of you, so I certainly understand if you don't have any questions, but feel free to say something or chat something if you want to. So let's look at the next one. So this next one it's kind of the same question, except not exactly, because the previous one was, what are the center and radius? This one is going to be graph. So graph 2x squared plus 2y squared minus 10x minus 2y minus 5 equal to 0. So I see it's a circle because I've got x squared and y squared. They're both positive and they have the same coefficient. So I know it's a circle. But I don't know the important parts about the circle, right? I don't know what the center is. I don't know what the radius is. I have to do the work. So the first thing, I'm going to bring the 5 over to the other side of the negative. I'm going to add 5 to those sides. So I'm going to get 2x squared plus 2y squared minus 10x minus 2y equal to positive 5. And then I'm going to divide everything by 2. So I'm going to get x squared plus plus y squared minus 5x minus y equal to 5 divided by 2 is 5 halves. Oh, I remember. So there was something I wanted to say on the previous problem. I'll say here instead. I want to point out the radius is not the square root of 5 here. Just like in the previous problem, the radius, I know when I brought this over, it was negative 11 fourths. The radius wasn't the square root of negative 11 fourths. Right? We have to finish doing the simplifying before we can say that the radius is the square root of what's over there. The reason I say this is because I've definitely seen a lot of people in the past be like, especially like it's been something that looked like a square number, like, oh, this was negative 25 and we added it over here and we're like, oh, well, the radius is the square root of 25. We have to finish the process before we can say what the radius is. It's not going to be the square root of 5 halves. It's going to be something else. Why do we divide by 2? Because, well, there's a couple reasons. One, we want it, well, maybe there's only one reason. It makes it easier to complete the square. So if we're completing the square, we need our coefficients of x squared and y squared to be just 1. And so whenever we know something's a circle, we always want to have our x squared and y squared have a coefficient that's just 1, not anything else. So that's the rationale for dividing by 2 in this case, or whatever the coefficient there might be. And I will also say, you'll know it's a circle because these, if there is a coefficient on x squared or y squared, they have to be the same. Right? If these were different, which they won't be for us, but if they were different, you'd have something else. Just want to say that. So then we're going to group the x's and y's together. So I'm going to have x squared minus 5x. I'm going to leave myself some space to complete the square. I'm going to have y squared minus y. Leave myself some space to complete the square. And then it's going to equal 5 halves. And then I'm going to have to add whatever I had here. I'm also going to have to add it here. And the same thing, whatever here, I'm going to have to add there. So I like to think ahead when I'm doing these completing the square problems. So for the x's, I've got a negative 5 as my coefficient there of x. I divide that by 2. And then I square it, which is going to give me 25 fourths. So that's what I'm going to add here. I'm also going to add it over here. And then for y squared, or for the y's, I should say, what's the coefficient of y? Is it positive or negative? Yeah, thank you. You're welcome to say words. You're also welcome to write it in the chat. I see a -1, exactly. So I've got a -1, so I'm going to take that, divide it by 2, and then square it to get positive 1/4. So, simplifying things, this is going to factor as x plus negative 5 halves, or just x minus 5 halves squared. This is going to be y plus negative 1/2 or minus 1/2 squared. And on the right hand side, I'm going to get a common denominator of 4. So this is going to be 10 fourths plus 25 fourths plus 1/4. Let's see, 10 plus 25 is 35 plus 1 is 36. So that's going to be 36 fourths. 36 divided by 4 is 9. So this is just 9 over here. Now we have to graph it. So we see that our center is 5 halves, comma 1/2. And again, the values of x and y that make each of these things 0. And the radius is the square root of 9, which is 3. Let's go to the other side. So if I were doing this homework on my own paper, I might use graph paper if I had it. Obviously not required. It's just kind of a pain to draw out these little marks. I'm usually not super concerned about these being exactly right, but it's kind of nice to know if we're crossing an axis or not. So our center was 5 halves, comma 1/2. So 5 halves is 2 1/2. 1/2 right there. So there's my center. And my radius is 3. So I'm just going to go 3 in each of the 4 directions. So I'm going to go 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, and 1, 2, 3 down. So there we go. Yeah. So down here, we're at the bottom of like negative 2.5. Up here, we're at the top of like 3.5. Here we're at negative 1.5, negative half. And over here, we're at positive like something. 2.5 plus 3 is 5.5. You don't need to write those things. I'm just trying to kind of show you where things are in case it's not super clear from my drawing. And again, this is 5 halves, comma 1 half. So that's most of what there is to say about circles. Really, it's all about the center and the radius. We like to write the equation of our circle in this standard form because it makes it really obvious what the center and the radius are. All right, I've got a couple more things that are not circles. Let me grab my notebook here. My notebook was hard to handle. So the thing we're going to start doing for the next couple classes is talking about some optimization word problems, which are probably not anyone's favorite, but it is important because there is a lot of optimization and word problems in calculus. So we need to kind of develop some competency and some literacy around those things. And so we're going to start off with an example that I hope is fairly straightforward, but it's really kind of, it's something we need to be able to do to interpret words into math, for lack of a better expression. So here is an example. It costs a restaurant $600 to provide a sushi buffet. I feel like this example was written many years ago. Charge $15 per customer. We want to find an equation for the profit, which we will call capital P, in terms of the number of customers, which we'll call X. I don't need a comma after that. So we have, I mean, we can talk, I don't want to actually get too into how all this works, but when you're talking about profit, you're talking about how much money you make minus how much money you spent, or revenue minus cost. Our costs here are the $600, right? It's a flat cost. It doesn't depend on how many people come to the buffet. We're spending $600 on the sushi and the employees and all the other costs, regardless of how many people come. Probably not very realistic, but it's all right. The revenue is how much money we make. So how much money are we making? Well, that's going to depend on how many people come. Right? If one person shows up, we're making $15. If 2 people show up, we're making $30, and so on and so on. So if X people show up, we're going to make $15 times X. And then the profit is going to equal the revenue minus the cost, which in this case is going to be 600. That's not the revenue. 600 is the cost. It's going to be 15x minus 600. And yes, I left off the dollar signs. We often kind of leave off the units when we are writing the equation. Although you could totally write $15 times x minus $600. That would also be perfectly fine. And you can either write this as P equals 15x minus 600, or you could write it as P of x to kind of indicate the functional relationship that P of x depends on what x is. Is there another letter under the P? Sorry, I didn't see that. Do you mean like here? Oh, it looks like you got it. All right, cool. All right. The second part of this question is, how many people need to show up to break even? So the question we actually kind of need to answer first is, what does it mean to break even? How much profit do we have if we're breaking even? Big old zero, right? You have zero profit if you're breaking even. So, okay, if we want to break even, that means we're going to set the profit equal to 0. So I guess I can do that down here. So we're going to set P equal to 0. That is, we're going to set 15x minus 600 equal to 0. And then we're going to solve for x. So 15x equals positive 600, and then divide both sides by 15. X equals 600 divided by 15, which is 40. So 40 people need to show up for us to break even. All right, we've got a minute left, but oh, is that the same? Where are my other example types? Yeah, I do. So I'm going to ask for a couple extra minutes of your time to finish this next example. I know we're almost out of time, but I would like to give you this example. I think it is important, especially if any of you are going to take physics ever. This kind of thing is definitely it also comes up in calculus. So bear with me for one more example. A ball is thrown upwards with a velocity of 80 feet per second, which is pretty fast because 88 feet per second is 60 miles per hour. It's kind of nice to know. The height of the ball as a function of time is given by h of t equal to negative 16t squared plus 80t plus 4. And the question is, when does the ball reach a height of 100 feet? Try to throw the ball up, and we're wondering, when does it get to 100 feet high? So what we're going to do, if we're given the equation for height, and we're asking what time is it when the ball reaches a certain height, we're going to set our equation for height equal to that height. So I'm going to set negative 16t squared plus 80t plus 4 equal to 100. And then I'm going to try and solve for time. I might bring everything to the right, so I'd have a positive coefficient, but I'm also going to have to factor out something anyway, so I'm just going to leave everything on the left and subtract 100. So I get negative 16t squared plus 80t, and 4 minus 100 is negative 96, equal to 0. And the thing you are going to want to notice here, and happens because it's contrived for a lot of these kind of height problems, is if you're in the US system, not the metric system, if you're in the US system, a lot of times you'll be able to factor out a 16. 16 comes out kind of, I don't want to say magically, but it happens a lot that we're able to factor out a 16. And we definitely can here. 80 divided by 16 is 5. 96 divided by 16 is 6. I'm actually going to factor out a negative 16. So I'm left with a t squared, left with a negative 5t, and left with a positive 6. And then I can factor this. Multiplying t squared, I'm going to multiply the positive 6 and add up to negative 5. So I'm a negative 3 and a negative 2. So let me ask you guys, what time is it in seconds after I've thrown the ball, or I should say, how many seconds after I've thrown the ball does it take for the ball to reach a height of 100 feet? What does t have to be? You guys can show me your fingers. You can write it in the chat. You can say words. So what does t need to be to solve this equation here? I see someone writing, yes, I see 2 seconds. But I also see and 3 seconds. Which seems maybe strange at first if you think about it, that it has 2 answers. But if we think about what's happening, it makes a lot of sense. What's happening is we're throwing the ball up, and at some point it's reaching a height of 100 feet. And then it keeps going up, and then it turns around and it goes down, and then it also reaches a height of 100 feet right there. So it reaches 100 feet going up after 2 seconds, and then on the way back down, another second later, it's at 100 feet again. So that's why there's 2 answers here. All right, I should stop because I've gone over time. I